Okay, so these are the notes that should be in your packet. And so we'll kind of fill these in with you. So x to the 1 over a, just like we were just talking to earlier, that denominator is the root. So this is the same thing as the a root of x, or the eighth root of x. Okay, now this one is a little different because it has a b on top of instead of the 1. So this is essentially x to the first power, but we don't have to write a 1 there when something's to the first power. It's just kind of understood. So when there is something else there, that is the eighth root of x, but then that has to be brought to the b power. Okay, so we can write it like this underneath, or if we want to, we can actually write it this way, the eighth root of x, and then bring that to the b power. Okay, because since both of these are really exponents, this is an exponent's 1 over a, this is the b power, they're both exponents, so they're in the same row on the whole like PEMDAS order of operations, so it doesn't matter which one you do first. This bottom part is just reminding you of the perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and we'll keep going. And then over here, when we're doing some examples of evaluating, this first part is actually just asking you to rewrite it in the other form. So this is given in radical form, so we're going to rewrite it as a rational exponent. Since it's the square root, that's the same as 47 to the 1/2 power. The second one is 11 to the 1/7. Again, the denominator is the root, so that changes it to the 7th root of 11. And we could write to the first power here, but 11 to the first power is just 11, so it's not necessary. Number 3 is the 300 to the 3/2, so that is the square root of 300. And then we're going to bring that to the third power. Oops. Sorry about that. And again, this isn't asking us to evaluate, just to rewrite it, just to understand how to go from one form to the other. And this is to the cube root of all of this is the same as bringing it to the 1/3 power. So this becomes 3 to the 1/3. And then a to the 5th is brought to the 1/3. That just makes it a to the 5/3. And then b to the 2/3. Okay? And then this follows actually just what we did earlier. This would be your 1/2. And your 1/2 would give you 1, which means the square root of x is x to the 1/2 power. And then on the bottom one, because we have 3 of them, that's broken up into thirds. So x to the 1/3 each time, which means the cube root of x is x to the 1/3. That's the big definition in this section, is just what those rational exponents mean.